Well, ahoy there, mateys. We are going to jump into 5.4, which is all about comparing ratios. So let's practice with this one right here. Now, you may not have perfect strategies for comparing things yet, but let's see how you do on these first two. So determine which car gets the better gas mileage, which basically means it gets more miles per gallon. So for number one here, we have car A that goes a distance of 100 miles in 4 gallons. And then we have car B that goes 95 miles in 5 gallons. So which of these cars do you think has the better gas mileage? All right, if you said car A, you are correct. This gets 25 miles per gallon, whereas car B gets 19 miles per gallon. So this one, if you find the unit rate, easier to compare those two. Okay, this one, not as easy to find the unit rate on. There may be another way to solve this one. So for number two here, we have car A that goes 341 miles in 22 gallons. We have car B that goes 270 miles in 15 gallons. Which of these do you think has the better gas mileage? Okay, if you said car B, you are correct. Now that one, not as straightforward as problem number one there. So we need some other strategies for solving problems like these ones here. So basically, when you're comparing ratios, for me, there's two really good ways to compare ratios. One way is to find the unit rate. So if you can figure out, like in this case, the miles per gallon for each car, that's an easy way to go. The other way is to find a ratio where one of the numbers is the same for the two things you're comparing. So like here, if we figured out how far they go in 20 gallons, each of these can be easily converted to 20 gallons. That's another good strategy. And that's where ratio tables will come in handy yet again. So for this problem right here, we have 8 tablespoons of hot sauce, and that's mixed in with 3 cups of salsa. That's in the green bowl. Then we have 12 tablespoons of hot sauce in 4 cups of salsa in the orange bowl. Which mixture is hotter? So again, just go with what your gut is right now. Which of these two mixtures do you think is hotter, the green bowl or the orange bowl? All right, now let's go through how to solve this using ratio tables. So first, you can make a ratio table for the green bowl, which is 8 tablespoons of hot sauce for 3 cups of salsa. Okay, and then you make a second ratio table for the orange bowl, which has 12 tablespoons of hot sauce in 4 cups. What they're doing here is multiplying this 3 times 4 to get 12 cups for the green bowl. And then you also have to do 8 times 4 because you got to multiply the top and bottom by the same. So for the green bowl, it'd be 32 tablespoons of hot sauce for 12 cups of salsa. And then the orange bowl, they're multiplying this 4 times 3 to get 12, the 12 times 3 to get 36. So the orange bowl would have 36 tablespoons of hot sauce and 12 cups of salsa. So what they did for each of these is turned them both into ratios for 12 cups of salsa. And then you can see, well, this one has more hot sauce, so the orange bowl would clearly be hotter. Okay. Take a second to look this over, make sure it all makes sense. But basically, this is one great way to use ratio tables, especially when it's not as easy to find the unit rate. Okay, so now we have this example here. Which bag of dog food is the better buy? So we have the top one here. It's 20 pounds for $17.20. Or we have 30 pounds for $25.20. So what I want you to do right now is either use a ratio table or maybe a unit rate or some sort of strategy to determine which of these is the better buy. Okay, now let's go through how you could use ratio tables to do this. So what they actually did is calculated the unit rate. So for this one, they did the $17.20 divided by 20 to figure out it was 86 cents per pound for this top one. For the bottom one, they did $25.20 divided by 30 and turned it into a unit rate, which is 84 cents per pound. So clearly the 30-pound bag is slightly cheaper by 2 cents per pound. Okay, so now this is one way of solving this. Not always the easiest way. Another way you could have done this, hopefully stick with me, see if this makes sense. This 20 and this 30 could both easily be turned into 60. So you could also take this 20 and multiply by 3 instead of dividing by 20. Do 17.20 multiplied by 3, and that'll tell you how much this is for 60 pounds. you would then double this and double this for the 30-pound bag, and that would tell you how much the other one is for 60 pounds. So you can, unit rate is not too difficult, especially if you're okay dividing, okay? In this case, for me, it would have been easier to turn them both into 60 pounds and compare what it would be for 60 pounds. Okay, so those are two good strategies for figuring out which is the better buy. And then this last example we have here is actually two problems. So we have a hot air balloon that rises 9 meters every 3 seconds. And we have a blimp that rises 7 meters every 2 seconds. So I want you right now to take a second to make a table for the hot air balloon and make a second different table for the blimp. Okay, hopefully your tables look something like this. So for the balloon, for 3 seconds, it's 9 meters. Okay, for 6 seconds is 18 meters. For 9 seconds is 27, 12 seconds is 36. So it's going up 9 meters every 3 seconds. For the blimp, it's going up 7 meters every 2 seconds. So 2 seconds is 7, 4 seconds is 14, and so on. So when will the balloon and the blimp be at the same height? Yes, at 6 seconds, they will, I lied to you. They will not be the same height at 6 seconds. That's what they circled here to show you that the blimp is actually 3 meters higher than the balloon at 6 seconds. So you can see which one is rising faster from the table. Later on, we'll be solving where these things are equal. That'll be later when we do some algebra. So here you can see the blimp is rising faster than the balloon. Okay, and then the other thing, this might be new for some of you, is then to graph these. Okay, so the way that's going to work is we have what are called ordered pairs, and some of you have done this when you've done graphing. Some of you have not done this at all, so this may be new for you. So this first point here of 3 seconds, 9 meters is written as an ordered pair in these parentheses as 3, 9. And then 6 seconds, 18 meters is 6, 18. 927 is here, and so on. And then there's these points also for the blimp. Now, when you graph them, and I don't think I have you graph too much where you have to plot individual points, but you might have to put a couple of points on a graph coming up soon. The way that works is for this balloon, for 3 seconds is 9 meters. You go over to 3 seconds, and then you go up to where 9 meters is, which is right here, right above the 8. And then that's that first little dot right there. So this is the first point for the balloon. And then 6:18, you go over to 6 seconds. You go up to where 18 is, which is right between 16 and 20 here. And you put another dot there. And this line here, this red line, shows you how fast the balloon is rising. And then the blue line here is the blimp. So 2 seconds is 7 meters. You go over 2 and up to 7. There's a dot there. And then 4:14, you go over 4 seconds up to 14. There's a dot there. So this blue line represents the blimp. Okay, again, for some of you, that is not new. You've done putting points on a graph before. For others, this may be brand new. So if you do encounter some issues using ratio tables to solve, finding unit rates, or identifying what graphs look like, see me or email me or see Mrs. Rude. So now is your chance to practice doing some 5.4s. You'll have a 5.4a, and then you'll also have a 5.4b a little bit later. So good luck, and I will see you during our next live session. Arr!